see me, or does the camera see my belt?
Well, now the camera sees me,
On the camera.
but you can take over.
Am I
If you
live?
hit, yeah, you're live. If you hit Windows 2, it'll take you to terminal.
All right.
Windows.
Boom. It doesn't see me. The camera loves you. All right. So, everybody, today is, I think, week 7 of CSE466. This is typically Michael's day, but I'm going to run through some logistics nonsense first, just to make sure we're all on the same page. Should be quick. So one of the things that we've kind of talked about for a bit now are new ROP challenges. These challenges do, in fact, exist. These challenges do involve JOP, as I've mentioned. We thought about and discussed earlier today, like, what is the best way to kind of deal with this, with where we're at as a class. Some of the ROP challenges were specifically like written to be difficult or harder than some of the existing ROP content. That we're going to move to program exploitation, so you don't have to deal with it now. The JOP content will be part of the pwn.college core yellow belt material. However, for the purposes of this class, I don't think it's totally fair to just be like, here's something brand new, do it now in ROP. I've been iterating on the JOP concept because originally it was way too hard. Like I'd throw these challenges at you and you'd look at it and just be like, what the heck is going on? I didn't think that was quite fair. I wanted there to be a good educational ramp to it. And so JOP challenges will be listed in 466. As part of a new module, which Michael and I have now sorted out kind of the details of how we're going to do this. On the 466 side, we're going to have a dedicated, I don't know what the formal name is going to be, extra credit module. This is separate from the 5% cap you get for playing nice on Discord and posting some memes. It's going to be a series of challenges that we add over the course of the semester. Each challenge will be worth about 0.5% of extra credit. For context, in a 30 challenge module, so like ROP, a challenge is worth about 0.25% extra credit. But remember, ROP has the walkthrough version and the hard version. So ballpark, these are just extra credit challenges that are roughly equivalent to what a challenge is worth in the existing modules. By the end of the semester, we anticipate there being somewhere between 10 and 15 challenges. There's no guarantee there. What it means is there'll be somewhere between like 5 and 7% potential extra credit if you want to take a stab at whatever challenges we throw there. For context, with like the JOP stuff that I'm working on, at this point I have like 8 JOP challenges. I'm not going to throw all 8 JOP challenges in this amazing extra credit module because some of them are super trivial and meant to be educational, not hard. And so what will be in the extra credit module is not super spooky ones, but not super easy challenges either. And it will grow out this as a way of adding challenges that you are free to tackle at your own pace, anywhere between now and the end of the semester for some extra credit. There is no checkpoint here. It's just flat extra credit, 0.5% per challenge. Any questions there? Beautiful. This is not, to be clear, a way of like sidestepping boss challenges in a module. I know that was a point of discussion on the Discord. Hard challenges should exist. Hard challenges should be assigned. This is just a different mechanism that we have now to include challenges that aren't necessarily core content for you to explore if you want. Cool. That says the same thing. Midterm exam, just as a general reminder, happening 21st and the 23rd in person, handwritten exam. You do get a cheat sheet. Show up then. Those dates aren't changing. Next week, I think Thursday, we'll distribute a list of what topics we're going to ask. It's not meant to be a surprise. You have some idea of what it is you need to look at. So you should have a week, 10 days to self-study, write your cheat sheet, etc. Along with that, we have a midterm module, program exploitation, on the topic of like boss challenges. It would be great if, yes, there we go. Okay, it's not when I look at it. So this is meant to be a culminating module. So when we talk about like hard boss challenges, program exploitation is meant to be a module of complex challenges, things that involve multiple components from multiple modules. So that means that a single challenge in program exploitation may contain elements of memory corruption, heap exploitation, ROP, putting that all together, making that happen in one module. It is meant to be difficult. It is not meant to hold your hand. Think of it as like an applied midterm assessment. Just fair warning for those that are working ahead, out of all of the modules, this one is probably going to see the most amount of rework. So if you are working ahead or planning on working ahead, I would not suggest working on those challenges. You're welcome to try them. We might reuse some. Demo plans. So do any of you have any burning questions for us about ROP? From what I've gathered, ROP is pretty chill. Is that accurate? You're free to say like, no, man, I don't get any of it. But like, it gives us an idea of what to do now. If everyone is good with ROP, like I plan on next week, or not next week, feels like next week, on Thursday, lecturing about JOP. Because there isn't that much to ROP, and we have a whole nother class between now and then. So I will focus on JOP on Thursday. In the immediate, one of the things that people have ran into then is you use ROP and you try and pop a shell, but it's not root. So anyone encountered that? You may have ran into it in shellcode. No, everyone's shells are instantly root. We're just pros.
There were some nodding heads out there.
Were there? Mm-hmm. Okay. I'm a little hard of vision. What do I need? Windows 2?
Yeah.
All right. Trust the process. Oh, holy cow!
That's it.
No, it's
fine.
Micro.
Oh, yeah, I can fix that. And no one. Do I have a challenge start? Yeah, there we go.
All right. Cool. So I want to do just a brief aside. This is not related to ROP specifically. About why, when you pop a shell, you drop permissions. So, first off, if we look at set UID, what kind of function is this? Is this a syscall libc function, or how do we know? Goes back to day one. Okay, so it says set UID 2. 2 is I believe syscall. So these challenges, when we look at them, they all have the set UID bit. What does that mean when we have this S here? And so the underlying mechanism of why all of these binaries concat the flag. Yeah.
It'll run the binary as the user runs it.
Cool. So the statement is when I execute this demo binary, it will run as the owner of the file, which is root. And so even though I am the hacker user, when I run this demo binary, it will execute a process owned by root. Now, part of that mechanism is this set UID, which is setting syscall, which is how you set a user ID more directly. Now, the root user is always 0. And we see this as a pretty simple syscall. There's set UID. It takes a UID T, which is just a number. If we were to search this guy. It is the ID that corresponds to the user. What is the ID of the hacker user, or how do I get it? Okay, it is 1000. That is correct. How can I verify that? There is literally an ID command. So this is my UID currently is 1000, which corresponds to the hacker user. My GID is 1000, which corresponds to the hacker user. And I am in the group of hacker. In the implementation of permissions, these names don't matter. All that matters are numbers. So let's make a classic do.c. We'll include standard IO. This is going to be the lamest program in the world. We're going to open /flag. Read only. And then we will send file to standard out. See if I can remember the arguments to send file.
destination file descriptor, source file descriptor, offset, bytes.
So destination followed by source, followed by
Offset, so let's do
offset, and then number of bytes. We'll go with like 80, some big number. Cool. Because the implicit declaration. Get my includes. Sys sendFile.h. Let's see if it's really going to yell at me for open or not. Yes, yes, it is. I miss when those things were warnings. We just ignored them. Sys stat.h include app control.h. And we're really just going to like poke at this and think about permissions. All right. That didn't work. But we can fix that. Am I in practice mode? Okay, I can't fix that.
You didn't specify. You didn't practice. So you gotta be specific.
The assumption should always be that you're in practice mode.
Let's start a new random challenge. There you go.
We're privileged mode. I forgot we changed the name, but that'll work.
There you go.
Thank you. Got to be careful. You're on somebody else's box. Okay. So I have this a.out. It doesn't do anything. Hopefully it's not because we programmed it wrong, but we can change the owner to be root. And we can chmod u plus s. This is what makes it set UID. Actually, this is not going to work for silly dojo reasons. Now that I'm thinking about it. So I'm going to move a.out into challenge. All right, it's owned by root, but it is not set UID. So we'll chmod u plus s challenge a.out. Now, if I challenge a.out, I get the flag. That's great. So what is different between what I'm doing here in my do.c and what you are doing in your shellcode or when you run? Michael here claims that there were some heads that nodded. So somebody ran into permission issues. What were you trying to do? Were you clearly weren't trying to just open and send file. So what were you doing? Like a lot of times what people do is they say, hey, I want to pop a shell, right? So what I want to do is I Googled online and I looked at cool CTF write-ups and I saw that if I write shellcode that does system bin sh, it's all over. I get a root terminal. Let's comment these two out. I need something. Right, we will GCC do that C. Maybe I will read a man page to figure out what to include. Standard lib. Oh, this caps lock, man. This caps lock is going to get. Okay. GCC do.c, sudo cp a.out to challenge a.out, sudo chmod u plus s challenge a.out. We'll take a quick look at challenge a.out. It's owned by root. It's set UID. Okay, I get a shell. Who am I? Hacker. What happened? Why? Any takers? I'm doing this by writing my own C program, but you are doing this, accomplishing the same thing by writing a ROP chain or writing shellcode. And so why the heck was I able to read the flag as root when I did send file, but I'm not when I use system? Any takers? We got someone back there. What do we got?
NSH is not set.
Okay, so the statement is bin.sh is not set UID. That's an interesting statement. It's true. If I look at bin.sh, it's going to point to, I guess, bin dash. And if we look at bin dash, it's owned by root, but it's not set UID. So that is a true statement. I don't think that is the cause here. In the interest of time, because I know Michael has some stuff lined up, well, we'll refer to our fancy man page. I used system because in a lot of CTF write-ups, they use system. It's cool to rely on the work of those that came before us, but it's always great to double check. If we read the man page, we have this mythological system thing that just execs whatever I want. What does it say it actually does? It says it is equivalent to execl bin.sh sh-c my command. Okay. So why does that matter? Well, if we look at the man page for, I'm going to go with, we're using dash, we said. Hiding in here is going to tell us, I can find it. There is a special flag that you can pass to dash specifically. It says, do not attempt to reset effective UID if it does not match UID. This is not set by default to help avoid incorrect usage of set UID root programs via system or POP. All right. Well, we know what a UID is. That's our user ID. What is an effective UID? Hopefully down here at the bottom, if we were to take a look at credentials, we're going deep into the man pages.
Oh, hold on.
What's up?
The laptop is stopped laptoping. We need to full screen this one. Yes, you can watch it in slow motion, essentially. That's going to crash my OBS, by the way, when I do that. So
Linux. How does it work? All right, so we're gonna. I'm just gonna talk to you, and the stream can get banned. So it turns out there's 3 different user IDs that are used when you're working with processes. Right? There's the UID, which is who is actually running this. So like when I exec a set UID,
we're good.
a.out, the process may be running as if it were root, but who's actually running it? The hacker user. So my UID is 1000. My effective UID is who am I pretending to be, right? So in a set UID program, what that is doing is it's setting your effective user ID. And these are all things that you can view with these type of like get UID, get GID, get EUID type of function calls. I don't think it's worth our time to write all these and just print out numbers. So my UID is, when I run a.out, my UID is 1000. My effective user ID is 0 because I'm acting as if I'm root. Now, what did the bash page say it was going to do? It said, hey, if your effective user ID and your UID are not the same, then it will drop permissions. How is bash doing this? How does bash know that I'm in a set UID context? Well, it's what I just told you. There's an EUID and a UID. If these values are not equal, then we will drop the effective to be whatever the UID is. This is specific to most shells nowadays. So like dash, bash, sh, all of those will exhibit this behavior. One way that you can get around that is by calling set UID before you pop the shell. is in my program here that I'm running in while I'm inside my a.out, before I call system, my UID is hex1000, my EUID is 0. So I'm acting as if I'm root. And if I'm acting as root, I can just be like, no, really, I am root. You have that authority within the context of this process. So if I were to do this, and I read a man page and figure out what I need to include. Compilers are so picky now. What do I got here? Sys types, bring in another. All right. We'll CPR a.out into challenge a.out. We'll sudo chmod u plus s challenge a.out. And if I were to run this one, all right, I still get a shell. You'll notice one thing that is different. Before it was a $sign, now it's a hash. And if I say, who am I am now root, at which point I can cat the flag. Okay, so this is a common problem that people run into in shellcoding. It's a common problem people run into in ROP. And we said that this problem was based in the behavior of binsh dropping permissions. And so one way that I can prevent that is by calling setUID 0 before I start calling shells that call shells. What's another way that I could get around this? I could just not spawn a shell. Now, if I would say I wanted to cat the flag, I want to instead do the equivalent of this, but I want to do this as root inside that process. Who is dropping permissions in my prior example here? binsh and system. So I don't want to call system, and I don't want to call binsh. But what I can do is we can use any one of these amazing execl family of functions. One of them has to not be pain, right? Let's do exec v. I'm already including what it needs. So I will exec v bin cat, and then my arg v here needs to be star arg v bin cat flag. Make this. I think that'll work. Maybe the compiler will yell at me. Let's find out. Let's see if I remember. Excess elements and scalar. Fine. Is it happy? It's still not happy. Why are you not happy? Chart star. Guess I would need to give it the address. RD. Is it happy now? It is still not happy. Gosh, dang it. When in doubt, just force cast, right?
Another start.
You want, I don't think you can do that. Because I'm getting the second address by getting the address thereof. So now it's mad at me.
Right, I only have a one shell rate, but you can store those stuff.
I can store the address of the array. I agree that the array is one-dimensional, right?
So it'd be constant.
No, it's not const. That'll be a warning on it. What do I got? I'm eating into your time
I think
now.
it should be a song from that.
Char star, this it's grumpy at me for my null byte string.
Just replace it with null. All uppercase.
You want this? All right. You'll have to believe me because I'm going to hand it off to Michael here. But if you were to call exec instead of system, then what you're doing is you are co-opting the current running process and immediately turning the current running process into bin cat. So there is no longer a UID, EUID check, and you won't drop permissions. Cool. All right. With that, Michael has something that is ROP for you to do. I will get out of your way now.
That is true. Track these. There we go. Okay, so last week I kind of gave away the whole barn by telling you guys how to do everything in ROP, and we got a lot of feedback that like, okay, well, why are all the levels the same? And it turns out the levels aren't supposed to be the same. It's just I kind of gave you chemical X that just kind of like blazes through everything. And so I wanted to take a couple steps back and just kind of really quickly double verify that like we're sure about everything that's going on. And then I also wanted to branch into a little bit more of an advanced ROP technique, which is called ret to CSU. So those are the two things we're going to talk about. Now, so just to remember, or let's do it like this. Let me go back to my old slides, just blast my Google Doc stuff everywhere. Nope. All right, that's a bad idea to do. I'll do that later. And so, no, you can't see the source code. That's a problem. All right. Okay, so what I've done is I've just spun up another demo challenge, and it's once again, it's a very simple, like very simple ROP challenge at this point. It's just this time I'm not giving you a libc leak, and really quickly I just wanted to kind of just reinforce the intuition that you don't have to go into libc to ROP. Like there are more ways to do this than just leaking puts and then just going, okay, I have libc, all the ROP gadgets are in libc, I'm done, right? And so there will be cases where you probably don't have access to this. Now, in my experience, it's very rare that you don't have access to puts. Generally, the cases when this happens, you're looking at something that's just not linking libc in at all, or they're doing some other weird input-output thing. But puts is usually pretty common, so it's a pretty safe approach. It's a really good one to have in your back pocket, but let's talk about what happens when you don't want to do that. So first thing I want to do is just quickly throw this up in IDA and show you what's going on here. Now, before I even start this, does anyone know of some ways that we can ROP and exploit without having libc gadgets? Like, for example, there's the obvious of just we have all the gadgets that just happen to be in the main binary. Like maybe it's a really big binary. You've probably noticed in some of these challenges by now, if you've opened up an IDA, that there just is a function that's like, oh, here's some free gadgets. Like we have this function in a lot of these. And so when you're dealing with like larger and larger programs, like these gadgets can leak in and they don't have to be sourced from libc. And so I just wanted to kind of go over the two main paths you exploit without going into libc. Now, the first one is when you have access to a syscall gadget. Now, syscall gadgets are, in my experience, like in terms of like playing like real world CTFs, like outside of pwn.college, like not super common. Like it's pretty rare that someone's just going to include a syscall like in their actual code and not like it being just in libc. However, if we run Ropper on this file, challenge demo, we will see that we do indeed have a syscall gadget in this binary because I put it there. And so really quickly, I just wanted to make sure that we understand how to ROP like with a syscall gadget without using libc stuff. Now, so let's go ahead and, oh, these are both on the desktop. Give me that. And so first off, is there any, I don't want to just do open read write flag. So does anyone have any alternative paths that maybe we could explore together that isn't just open read write flag? Like, what are some other ways that we can get access to this? Pop a shell. You want to pop a shell? Okay.
Seems relevant to what we're
It does seem relevant to what we just learned. So let's go ahead and try to do that. Now, let's really confirm if you were paying attention. What were the 2 steps that I have to do to pop a root shell?
set UID and then system.
Bingo. And so if we go to our syscall table, we have a set UID syscall, and we don't have a system syscall. We do have exec VE, so we could look into that. And then I do not believe, so I think if we wanted to call system, we'd probably have to leave libc.
Just do chmod, it's weird.
We could do chmod. Yeah, actually, I kind of like chmod because then I can talk about using strings in the binary again, which is also something that's really, really important to understand how to do. So yeah, let's do chmod. Okay. Sorry for taking you over. A fist fight is breaking out in the crowd. That's a joke. Okay, so let's get a script started. And so let's go to solve.py. Is my terminal big enough for everyone to read this? I guess I can make it a little bigger. All right, and I guess I can also use this button. All right, so a couple things to remember. Set your architecture. 64, and then I'm just going to spawn a process here. And then let's see. So when we run our binary, you're running IDA, you are storing that. Wow, I can't zoom in on both tabs at the same time. There we go. So first thing we're going to do is just grab our binary. So remember, in this case, this binary is PIE, and then I've given you a leak. There's other ways to do this. For example, if you didn't have a leak and it was non-PIE, I really hope that doesn't happen a lot. And it was non-PIE, you wouldn't have to go in and recalculate all these offsets. But in this case, we've got a leak. We're going to use it. And so we can scrape that out really quickly. So p.receive until, and then that's an SSH key. That's okay. It's the public one. You can authenticate me. And then we will do p.receive line, p.receive lint. I'm going to strip off that last new line character, grab our leak. We know that this, from looking at the output, is just a 16-byte integer or hex integer. Geez. And then let's print that out just to double check that everything's going right. Do. Bingo. All right. So we've got our number. I'm going to print that in hex just to double check. And then what we can also do is make our elf object in pwn.tools. This is just because I don't want to have to do the math myself. And so I just want to let pwn.tools do the math for me. And we are going to say e.address is equal to the leak minus the offset to main. So e.symbols main. All right. And then we can print this out and say binary base at do.address like that. And at this point, we should have our leak. Ah, come on. My terminal's too big. Oh, fuck. Oh, that's not how I spell that. All right. So we've got our leak. Everything's looking sane. We've got 3 zeros on the end. So now we can actually begin wrapping. Now, we're going to take some shortcuts here just because I wrote the challenge. I know some of these numbers. Hopefully at this point, you guys know how to find the offset to a return address. And so I can just start building my chain. So we're going to say rot chain equals, and we are going to put down, let's say, I think it's 88 A's off the top of my head. We could go in and verify this. We could use a cyclic pattern. We could look in IDA. We could just look in GDB. You could just guess. Guess and check is always a fun way. Then let's do our little guess and check here. And then I'm going to change this to a gdb.debug. I am becoming more and more and more of a fan of just using GDB debug permanently. This is a workflow change that I've been really a fan of recently, actually. I've been playing like personal CTFs using just only GDB debug, no more process. Just give me GDB. What was I doing? Lost my train of thought. Checking this. I need the context.terminal line from my IPython history, because I store things in my IPython history like an insane person. And then that needs to go above where we spawn the challenge. All right. All right, so now we get there. And so now we should be able to see that we did not crash. So I did not, well, I forgot to send in my input. That's what happened. e.send rock name. There we go. And if we look, we can see like cannot disassemble from PC. And then we look at, we're about to ret, so we're about to pop that top address off the stack. And that is full of all the Bs that we just put in our file. So now we're set up to start ropping. So we wanted to go ahead and chmod, and we have a syscall gadget. So let's go ahead and look at setting this up. So I'm just going to copy this guy out and drop him in a comment over here. Then let's just do some very minor labeling. RAX, RDI. I can never remember the orders. These RSI. That's why we have references. All right. And so what's my first step? Hopefully we've done enough ROP to know what my first step at this point is.
Dropper into a gadget swap.
Bingo. I need to find some gadgets. So my preferred way of finding gadgets is to use Ropper. You can also use Pwn tools. You can also manually look for them with object dump, whatever you want. Don't. If it works, it works. So we're going to grab a pop RAX gadget, which we can see there's one right here at offset 1517. I could use the Pwn tools ROP gadget searcher thing, but I know the offset is 1517. I know that my e.address for this elf object contains the true base address of the binary. So I can just come in here and say 1517. And then we are going to add that to e.address. And then that is a pop RAX gadget. So then we also need control over RDI and RSI. So we're just simply going to find those gadgets as well. So 151F contains a pop RDI. It's 151F. Then we need an RSI. Here's a pop RSI. So 1527. Now, note, if we didn't have this pop RSI, we also have this nice convenient gadget above here that's pop RSI, pop R15 red. So let's throw a little bit of a wrench into this and use the fun one with two pops just for fun. So let's go pop RSI, and then that is also a pop R15. Just simulating a complex condition here. Oops. 6-1, I believe that was. Yes. All right, so we've got our three gadgets. Now let's assemble our chain. Oh, we'll also need a syscall gadget. Forgot about that. Let's find that syscall gadget again. So 154F. Anyone have any questions so far about just finding gadgets? Okay, hopefully familiar at this point. Checking Twitch chat, nothing there. All right. So then we can start building our ROP chain. So we no longer need these Bs because we know that that's where our return address is. I'm going to move that down, and then we'll start building. So first thing I'm going to do is just set up all my arguments. So the first two that are pretty easy is RAX and RSI. So let's say pop RAX, and then I need then 8 bytes for this ROP gadget to pop off the stack into RAX. We want the syscall number of 90. So we're going to be P64 and then 90, or we could use that hex 5A. Then let's go again. So we're going to pop into RSI. And then remember that we also have that R15 to deal with. So pop RSI, pop R15. So now we need the basically some value here. We'll get to that. or if anyone just happens to know off the top of their head what the proper chmod value is.
So.
But the trick question is yeah. So we can enter this in octal. All right. And then so finally, here's our last fun bit to sort out, which is that RDI is a pointer to a file name. And so how do I figure out, like, so this has to be a pointer to somewhere I know. And the only thing that I know at this point is where everything in the binary is. So I don't have access to libc. So the first thing that we could do is we could say, okay, well, I need a pointer to /flag if I'm trying to hit /flag. And if maybe I come into IDA, I go to my subviews, I find my strings. Let's reset that down. That is horrendous, but we'll deal with it. It's small to see, but the point is that there's not just a clean /flag string, or at least if there is, I'm not seeing it in here. And so now we run into this problem where I need a string, but I don't have the one that I want. And so there's two ways that we can kind of remedy this. We can either, one, try to insert our own string into the binary, or we can leverage an existing string in the binary. And which one of those two you choose depends on kind of the security story of the challenge you're working on. In pwn.college, you have access to the underlying system that this challenge is running on. This means that you can just kind of arbitrarily make files in your home directory, that kind of thing. So we can use whatever string we want because we can always just like make a symlink to the flag, for example. However, when you're doing like maybe like another CTF challenge where you're like connecting over netcat, you don't have the ability to just make an arbitrary file on their system. Like if you're doing that, you're probably already winning to begin with. And so it's important to kind of think about like what your goals are and what your constraints are when picking which one of these approaches works. Obviously, inserting a string is going to be more robust than trying to use an existing string in the binary, but it's also harder. And like if you have payload constraints or other just bizarre constraints that you might have to deal with, then using an existing string in the binary can be a really good way to get around some of these. So let's go ahead and use a string in the binary. So let's see. Which one do we want to use? I think you want overflow? All right, we're in. So we're going to use this string overflow, a 64-byte buffer now.
Beautiful.
And this is at offset 20BF from our file. And then I can zoom back in here. And so what we can say is, okay, so our target string is at e.address plus that offset that we just saw, which is 20BF. One thing that I also like to do is just confirm this for myself. So like we can very easily go into GDB, grab our base address, and then just double check that that offset maps to that string. So 20BF. Okay, everything looks great. There's our string. And then I'm going to copy this out because we're probably going to want it. So there's that string. And so here, and remember that this is the address to that string in the binary. And so by nature, it's automatically satisfying this const char pointer file name. We just have to have a file that happens to be named exactly this. And if we take this and just drop it into a terminal and make a file, we have a file. So let's go to my home directory. Actually, let's go into the rock demo. And then let's go ahead and open this up. One too many quotation marks. Oh, I'm an open source VS Code user. There we go. And then let's fill this with just like something. Now, at this point, we could chmod this file, but what we really want to do is chmod the flag. So I got ahead of myself a little bit there. We actually want to create a symlink. So ln-s, and if we didn't know the order of which of these arguments went to which, we could remember read the man page, but it's what you're trying to link to, and then the name of your link. And then remember, you need that -s to make a symbolic link. And so now, if we try to cat this file, we get that permission denied. And if we take a look at this, we can see that this is indeed pointing to the flag. So now let's try to use it. So we need to get into RDI. So we have a pop RDI gadget. ROP chain plus equals P64 of our target string. And then finally, we should be able to just make our syscall. So P64 syscall. All right. So we've kind of taken a YOLO shot at our ROP chain. And now let's go ahead and actually step through it, debug it, make sure that it's working properly. All right. So whenever I'm debugging a ROP chain, the first thing I'm going to do instantly is just find the return that triggers my ROP chain and just drop a breakpoint there. And we know in this case that we're returning from main. If we didn't, we could look in IDA. And so I'm going to disassemble main and break it star main plus 132. Note that if I was doing this a lot, what I probably would do is come in here and set it as GDB script in my gdb.debug call. So just something to remember is that you're not having to type this out every single time. And now let's go ahead and start looking. Oh, oops. What do we got? Can't concat into bytes. I forgot to P64 that. All of these should be P64. P64. Just because remember, these are addresses, so we do have to pack them to put them in the program. Let's grab that breakpoint. Oh, it's not in my history. Oh, well. All right. And so now we're at the start of our ROP chain. And pretty much at my process for this is just kind of stepping through it one by one and just verifying that the results of what I think is happening is actually happening. And so the very first thing that we tried to do was we tried to pop 90 into RAX. And so I should be able to step past this RAX or pop RAX and see that value of hex 5A or 90 appear in RAX. Good, done. Similarly, we have this pop RSI R15. So pop, and then let's check to make sure our RSI is set to that right value. That's that hex 1FF that we need for chmod. Then we have our pop RDI gadget, which let's step one more time. Remember that this pop RDI gadget was supposed to point to our file name, which it's now pointing to overflow a 64-byte buffer now. So everything's checking out. And finally, we look at our syscall, and then hopefully we would be winning at this point. However, I'm running in GDB, so I'm assuming that this is going to, return with an error code. And so now let's get rid of that gdb.debug and see if this works. All right. And then we cat that, and we get our flag. So we've chmodded successfully. Now, does anyone have any questions about this? Because note, at no point did I leak libc. I did not have to puts. I had a syscall gadget. Now, what happens when we don't have a syscall gadget? Like, obviously, this becomes a little bit more difficult. However, what we have to remember is that we have the PLT and the GOT that are in our binary. And remember, like, if you remember back to my puts lecture, the fundamental reason that puts works is because we leak something out of our binary, and so we know where the binary is. And at this point, we know that there are locations in the binary that point to libc. Like, that's how these things connect together. And so we can essentially use these as stepping stools to get to where we want. And so when we go and look at our PLT, which remember, we can go to View, Open Subviews, Segments, and then we can look at our GOT and our PLT here. We can see here's all of the functions that I, in theory, could access from just this main binary. Because in theory, these are used in the program, and then when they are resolved by resolving that PLT entry, the actual address in libc is going to be showing up there. And then we can pop those into RIP with a ROP gadget. So sadly, we don't have chmod here, but let's go ahead and use exit just as like a quick little barometer. So in this case, rather than saying, okay, I'm going to rep to syscall, I could say I'm going to ref to e.symbols and then exit. And then let's run that again. Oops, not that terminal. And so we can now see that my process has stopped with this exit code of 191, which is very different to the case if we undo this one change. So that's how we could call a function without having access to it. So see, now we're segfaulting because I didn't run that exit. And so those are just two ways that you can ROP without having to do puts. So are there any questions about that? Okay, now I want to pivot into the complex, a little bit more fun technique. And so in glibc versions, I believe prior to 2.34, there is a function in the initialization process of these binaries that is called libcsu init. And basically, this exploitation technique was, I believe, presented at a Black Hat in 2018. And the idea was that these people just found a place in libc where there just happened to be a very powerful ROP gadget that you could leverage. And this libcsu init function contains this gadget. And to me, there's two parts of this. You can probably already see one part of it, which is just like 7 pop instructions in a row that get you control over a lot of registers at once. That's great. But the real place that this gadget becomes powerful and sort of the hinge point that makes this interesting is these 4 lines right up here. And so I want to show those in GDB really quick as well. I'll pull those back up in a second, I swear. Let's see, let's see, CSU init. Essentially, these 4 lines right here are very, very interesting because if we look at what happens when we combine these gadgets, so if we run this gadget, we get control over these 6 registers, like RBX all the way to R15. And then when we call this gadget immediately after, note that we have control over R14, R13, R12, R15, and RBX. And this gives us direct control over RSI, RDX, EDI, and then allows us to make an indirect call. And so this becomes very, very powerful very quickly because you might be looking at this call line going like, okay, well, crap, that's just going to crash my program. But what happens if we set RBX, because remember, we control RBX with a pop here. If we set it to 0, now we just arbitrarily dereference R15 and then just call the address that's there. And at this point, we can transfer our control flow. So for example, this is a very easy way to like set up a syscall, for example. Like if we had a syscall gadget, but then couldn't control any of the registers to make a syscall, like we couldn't control RDX or RSI, this ret to CSU attack would help us do that. Similarly, we could also call like libc functions. So maybe I wanted to call like chmod here. And so what I want to do is just show you really quickly how to call exit using ret to CSU. Because ret to CSU is a very cool technique. It's powerful. Just note that it is deprecated in like the latest libc versions, but there's still some legacy conditions where these functions still can leak in modern versions. I'm not 100% sure on the specifics. I guarantee if you Google it, it'll probably fall out. But there are cases where this can be useful, and I think showing ret to CSU is important because it's just one example of how gadgets can be more powerful than like they initially appear. Like there's a constraint solving process that happens. And so I want to grab all of this. And one thing that's nice is because we haven't actually ran anything in libc yet, libc is just showing us the offsets from our binary base. So we don't have to think about recalculating any of these. Let's get rid of this terminal. I don't need it. Then let's comment out all this. All right, so here's our little section in libcsu init. And I like to think of this as basically 2 distinct pieces. You have like a popping gadget, and then you have a calling gadget. And so I want to set up both of those. So we'll say like our popping gadget is equal to e.address. Remember, this is the base address that we leaked earlier. And we're going to put that right to the top of these pops. So this 163A. Then we have our calling gadget, which starts at this 1620 up here. And so now we just have to leverage them. And so let's get started. So the first thing we need to do is just call this popping gadget. And when we get to this popping gadget, there are going to be 6 pops that run in a row. So this means that we need to add 6 additional 8-byte sections to handle every single one of those pops. And at this point, this is also just a good reminder that you might not have this much space there. So this could be like having like this is going to be like 10 plus like 8-byte sections. And so you can start to see where stack pivoting can become required when you're doing more complex ROP operations, especially when you have to deal with like this game of like, what gadgets am I using? How am I solving this puzzle of trying to like set RAX when I don't have a gadget to pop into RAX? And so, so let's go ahead and get 6 of these down, and then I'm just going to comment every single one of them. So this one's RVX, RDP, R12, R13. And this is one thing that I do like doing, which is just kind of like scaffolding out my exploit before I really start to reason about like what constants I'm going to need, just because this is the general flow that I'm going to be following. And then we next need to go to our calling gadget. So P64 calling gadget. And this gadget, all it's just going to do is call, no pops, so we don't have to put anything after this on the stack. But we do have to reason about what these registers are actually doing. So in this case, R14 is indirectly controlling RDX. So I'll write that down. How did that appear? Go away. There we go. RDX. Then R13 is indirectly controlling RSI. And then R12D is indirectly controlling EDI, which all this means, remember your register sizes. If you didn't remember these, you could look up a register table. So R12D is those lower 4 bytes of R12, and EDI is the lower 4 bytes of RDI. And so we get control over most of the register. Remember that when we perform a 32-bit operation, it's going to zero out those 4 higher bytes in that register. So we effectively can get control over the entirety of the RDI register. It's just we're constrained here that the top 4 bytes have to be null, which in most cases, this is fine. So R15 goes to EDI. Or sorry, whoa, R12 goes to EDI. Almost oopsie. And then finally, we have RBX and R15 that we want to use. Now, in order to make this call work, my universal advice is just to always set RBX to 0 and just forget about it, so you don't have to deal with doing this like multiplying by 8 math, because 8 times 0 is 0. And so we're just going to set that to 0. We're going to forget about it. And then now we can just set R15 to whatever the heck we want. So R15 is where we want to go. And so in this case, let's see. We'll talk about where we want to go in a second. Or maybe it makes sense to do it now. So when we run this call instruction, if we assume that RBX is going to be 0, you can just forget about it. But what's going to happen is we are going to dereference R15 once and then call that address. So what I can't do is I can't just come down here and go, okay, I'm going to put exit right there, because it's going to try to dereference that value once, and then you're going to eventually end up trying to call the instructions at the top of this function. And so what we really need is a pointer to exit. Now, where are pointers to functions living in my binary? PLT. And so we can go into IDA and find that address of exit. All right. And so we find where exit lives. So 3FC8. And then we can put that here. So e.address plus, what was that? It's 3FC8. And so remember, what's going to happen is R15 is going to contain the address of this PLT entry. We dereference that once, and then the 8 bytes that it's going to call is the actual address to the function exit. This is the confusing part of ret to CSU, so I just want to pause to make sure that this makes sense to everyone. Okay. So now all we got to do is start just controlling our arguments. So we want to make an exit call. So really all we worry about like is our exit code, right? What argument's my exit code in? Got it, RDI. So let's set that. And let's just go to 1337, or let's do 42. There we go. I recently did a CTF challenge that was themed around Hitchhiker's Guide to the Galaxy. It was awful. And we should be able to get away with the rest of these being null. So let's go ahead and try to run this and see what happens. But I am quickly going to change this to gdb.debug so we can kind of take a look at what's happening. Oops. So once again, I'm going to disassemble main, put that breakpoint right at the bottom. All right. So first thing that's happening is we're going to that popping gadget. Remember, this is in libcsu init. And so we're going to be popping these next 6 entries off the stack. And so we can kind of just watch that happen. So let's make it bigger. SI, 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 SI. And then at this point, we scroll up and we look, boom, we've got control over our gadgets, or we've got control over our registers. And then now we can head into the calling part of the gadget, SI. So we're going to move R14 to RDX. We're going to move R13 to RDI. We're going to move R12D to EDI. And then we call our pointer. So we're going to dereference this. And just to quickly show you that this is going to where we want it to go, if we do the math here, and then we print to the 8 bytes that are right here, we can see that that is indeed the exit GOT-PLT entry. And then if we look at here, we can see that that is indeed the first instruction of the exit function. So by stepping once, we go straight to the exit function. And so now I can continue, and then my process exits with exit code 52, which, interesting. I think that's what we wanted, right? Maybe. Interesting. Maybe? Oh, let's try that. Oh, okay, there we go. GDB, I don't know what's going on with GDB. It was lying to us. But child exited with status 42, definitely winning there. Now, ret to CSU is very powerful. There are some notes here. First off, in order to use ret to CSU, your stack does have to be aligned. So just be careful with that. Like you have to be 16 byte aligned, just like with the XMM instructions. In terms of using libc or using this technique, like there is a built-in way to do this with pwn tools. So if pwn tools ROP ret to CSU, there is a fun little function that will do this for you. So pwn tools does have a built-in ret to CSU builder, and it will go through and basically do exactly what we just did for you automatically. So this is a technique that, because of this, is very easily to just kind of rapid fire. So it's one that I actually kind of like to keep in my back pocket for like when I'm doing CTF challenges. Just do note that once you hit those modern libc versions, libcsu init disappears. And if you're curious, you can actually go read the patch where they patch that out. And they go, all the maintainers are like, I don't really understand ROP. And then there's this one guy that shows up and goes, we should patch that out. It's great. In terms of other ways you can abuse this, you could think of calling back to _init to start your program. You could think of calling like into anything. You can even repeat this like multiple times if you can find a way to call to somewhere back to continue your ROP chain. Lots of different ways to do it. Does anyone have any questions about this? Question? No questions. Wait, maybe? Hold on. Home college subathon when? Good question. Okay. So I guess I've got 5 minutes if there's any lingering questions about ROP or anything that we've gone over. Okay,
About pivotal pursuit.
pivotal pursuit. So it's worth mentioning that Robert did do a pretty in-depth talk about stack pivoting on Thursday. But the whole point of pivotal pursuit, if we go and just take a quick look at it, I'm not going to give this away. But essentially, if we look, you have to be careful because you're not given a lot of leaks in this case, right? And so we have to start being careful about how we reason about things. And I guess, like, do you have a specific question or maybe just like how to approach? Like,
Um, so within the win function, it makes a syscall for you. It has an open field permissions. And how you start to get that about.
let me see if I can find what you're talking about. Let's pull this up in IDA. Grab our win function.
You want to get to copy. Of that, then copy.
Got it. And then your question is, we're doing this in a way that drops permissions?
Well, it opens it with permissions where you can't read the copy.
Got it. Opens it without permissions where you can't read or write. I'm not seeing anything that would stop that. Is there something I'm missing here? By my eye, if you can get here, you should be winning. Correct me if I'm wrong on that one.
I wasn't fully listening. Something about permissions.
The question was that there's something we're doing where we open the flag where you can't read or write it.
It's open with 0, I guess, the second one.
Yes.
Is that prevent reading, right?
I don't believe so, but we could probably find it out by looking at the man page. That's not the right one. No, that was the right one. And so if we have 0 flags and 0 mode, I believe that should work.
Wait, what's the ask with open?
If you open it with 0, does it allow you to actually read the contents of the file? I think what's happening in his case is that he's getting to the win function and then it's not being able to open the flag.
Yeah, I do that.
So I verify that you're not running under GDB, verify that you're not running under a weird, like, sometimes people copy the binary into their home directory to do like weird surgery to it. I can't think of any other reasons why that wouldn't work off the top of my head. Oh, well, you're just looking at the representation of it. Because if I did I should see it in here somewhere. Interesting. Let me double check with you after class. But in that case, that's all we got for today. Goodbye.